use the channel SQL Coding series to ask your questions. We have discussions going on in there on all that have been discussed, all that we have shared, and we also look forward to having your questions. I'm sure we must have questions and clarifications at one point or the other that we need to be, shared and clarified. So please use the channel SQL Coding series to keep the discussion ongoing there, and would have all your questions answered. One more thing I had mentioned earlier, that please ensure your chat is tuned into everyone so that we'll all have access to your comments, your questions, and use the Q&A section to um, put in your questions, fill in your questions in there, and would attend to those questions as we move on in the webinar. So once again, you're welcome. Great to have you. It's nice to have you around, and I'll be welcoming and turning over to our facilitator for today, Sneha. She'll be taking us through the advanced series. So Sneha, you're welcome.
Thank you. Hi, everyone. Give me 1 second to start sharing my screen, and then just 1 second. There. Okay, can you guys see the screen now?
Yep.
Yes, we can see.
All right, perfect. Okay, so yeah, hi everyone, and welcome to the last session in our SQL series. I think it's been a fantastic series so far. If you've joined us for any of the past 4 sessions, I'm sure you will agree with me that all our wonderful speakers have taken us through various concepts in SQL, and this one we thought we will close it out with sort of the advanced session with some of the topics which are maybe a little more complicated than some of the things that we see. Okay, so I am super excited to have you all here. Before we jump in, just a couple of reminders. If you have any questions as we go through the different slides, please drop your questions in the Q&A box. Sometimes it's easy to kind of lose them. And somebody from our team will get to those as we go through the session. With that, let's talk about what we are going to address in today's session. Now, you see only 3 topics listed here. If you have kind of looked at SQL books or a lot of different resources online, you might see several different topics which are categorized as advanced. It's not really possible to dive into all of them within the time that we have. So we handpicked a few which are more commonly used or seen at work, in professional settings, maybe in projects, and certainly from an interview perspective. So this is what we will talk about: subqueries, window functions, and common table expressions, which are also called CTEs. With that, let's jump into subqueries. Okay, so I think last 2 sessions, or perhaps the last one, was a lot of deep dive into joins. When you have multiple tables and you want to get data by connecting to both of them or more than 2 of them, you typically use a join. There is another way of doing it, which is essentially what subqueries are. So they are, they pretty much serves the same purpose of what a join does. And you guys might wonder, so why do we really need these subqueries? And we'll talk about that in a second. So subqueries are essentially, for anybody who is not super familiar with that, it's like a smaller query that is nested within or is inside of like a larger SQL query. So we'll go to the syntax in just a second, and I can explain a little bit better what that means. But before we do that, let's talk about some of the use cases. So you can use subqueries if you want to like aggregate in multiple stages. What that means is if you had two different tables and you wanted to first aggregate data in one table, which means group by one of the columns and get the sum, average, min, max, any of the other functions that we talked about in the past sessions. And then you wanted to kind of join it to another table and get information from there. So that is how you would aggregate in multiple stages. You can use it in conditional logic, which is your like where statements, and then you can also use it to join using subquery. What that means is if you have table A and join it with a portion of table B, you would essentially write a subquery for table B, and then you would join it. Now, this might sound a little vague because we're not looking at examples yet. So let's jump. Okay, so here we have two different examples. Let's look at the one that is on the left. Here there is a table where we have for different customer IDs the first name, last name, age, and country. And here, what we want to do is we want to show one way of using a subquery. So in the block of code that you see on the page, there is in the where clause other select smaller, which is in between the path. So that is essentially your inner query or subquery, which is sitting inside this larger query, which is inside the
and sorry, Sneha, to interrupt you. A lot of people, and I also have an issue with your sound, I guess. Like it's breaking a little bit. Yeah.
Okay, let me stop my video and see if that. Can you guys hear me?
We can hear you, but it's breaking, I guess.
Okay.
Are you using headphones or something?
No, I am not.
Oh.
I'm not really sure what I can do to change
Yeah,
that.
it's better now. I think you can keep your video off. Also, can you like zoom in a little bit? I think 2-3 people are saying that the text is a little hard to read.
How that would work.
I think it's an image, that's why it's not like.
Yeah, I think it's an image, so it's a little hard for me to
Yeah,
zoom in.
we'll share the slides and she's explaining anyway. So if there's any doubt, still you can ask in the Q&A box.
Yeah. Sorry about that.
No.
Guys.
Carry on, please. Thank you.
Yeah. Okay, so we repeat very high level that left image. So we have a table customers with the different columns that you guys hopefully can see. And we're trying to get some output from there. Here we are demonstrating one use of the subquery. In the where clause, we see it is where age equal to, in parentheses, we have like another SQL statement making up a smaller query, which we call our subquery or inner query. And it sits within your larger query that is in the purple box. So essentially what happens here is the inner query or the subquery gets kind of evaluated first. So here it will, when the compiler goes through your code, it kind of goes to the portion of the subquery first, and it will get the minimum age from the table of customers. And that should be a singular value, right? We're just getting the minimum value of the column age. And then in the where statement, we just get age equal to whatever that output of the subquery is. So that is one way of using it, where you get like a single output from your subquery. And that output is used in your where clause or anywhere else in the other output. So like a super simple example, explain that use case. So the next one is on the right, which is very similar to what we just spoke about. Here, the difference, if you notice, is in the where clause, we are saying customer ID in, and there's no equal to sign. Because what we're trying to do here is we don't want like a singular value of the customer ID. Instead, we want the list of different customer IDs from this orders table. And for all those IDs, we want to get the first name and the customer ID from the customer. So this is actually where it looks very similar to what a join would be. If you had to do this in terms of a join, you would just take the customer table, take the order table, and join them on the customer ID. Any questions so far? All right. So moving on, I wanted to do the examples first because we spoke about some use cases. We have the subquery structure a little bit more, right? So like I mentioned, within the parentheses, you usually see the inner query, and it can be anything depending on what you're trying to solve for. It's also like general practice, even like in here, they've used the alias of SUP or sub or subquery. Then that sits within your bigger or outer query. And you can pull again, you can even join multiple tables on that. You can do a lot of fancy stuff. So that's basically what the structure looks like. And first we evaluate the subquery, and then the output of that is used by the outer query. So I mentioned that subqueries and joins kind of do the same thing at the end of the day. Now, in many cases where joins are not super complicated, it is better to use a join and not a subquery, because a lot of the platforms or the databases that we use, the join is what is more efficient and optimized. So subqueries can make your overall query inefficient and slow and resource intensive. So why should we use subqueries at all, right? Why can't we just live with joins? Several times there's like many, like more than 3 tables that you are using and you need to join with. And you could have a lot of filtering conditions on 1 or 2 different of those tables. So your query tends to get very complex, and there would be different joins that you're working through. It becomes hard to read, and it can again become resource intensive too. In those cases, if you instead choose to use subqueries in all or some portions, then it can make your code more readable. It's easier to debug if you run into errors. And yeah, in any case, the query might just be as efficient or inefficient either way in those scenarios.
Sneha, there was a good question related to that last slide, if I could interrupt for a moment.
Yeah, please.
So the question was, what does joins are optimized mean? Could you please provide an example?
Okay, let me try to think of an example. I guess what I was trying to say is, we looked at the previous example, right, of this one on the right, where we have two tables and you just want to work with those. It looks fairly straightforward. Now, if I were to do this way, as it is shown here, using the subquery, versus if I just did a join between the two tables using the customer ID column, it would be faster from the compiler standpoint to do the join, instead of going into the subquery first, evaluating it, and then populating the output, which is used by your outer query. So that is what we mean by joins being more optimized. Subqueries, because they require those kind of like multiple step operations and evaluating queries twice, so to speak, right? Like you evaluate the inner query, get the output, then you do something with it to evaluate the outer query. That makes it a little inefficient compared to a join. Okay, so let's move on to the next piece, which is window functions. Okay, so these are also sort of similar to another concept we've seen in earlier sessions, which is group by. What these do is essentially calculate or come up with aggregates based on a certain grouping of rows. But the big difference, as you can see in the image here, is the output is not condensed into a single row per group. And again, we look at an example to illustrate that better. But basically on the left is what you would do using a sum function or an average function by using a typical group by statement, where let's say you group by all of those, like the blue, the column in blue, right? So everything is now grouped into a single row, which is your output. And here you get the sum of whatever values were there in this column across all the rows. When you instead use a window function to do the same thing, let's say sum, then you still get the sum of all the three rows for this column, but in your output, you still have three rows and not one. So that is kind of the difference between using aggregation or a function with group by and using a window function. So here is the syntax. This again is used or can be used in different parts of the SQL query. One of the common uses is to use it in the select statement. You could also use it in like a where clause. So since select is like the more common function, I just put the syntax for it, but the same syntax can be carried over in a where clause if you wanted to use it in a where clause. So let's look at this, this second row where it starts from. So here window function essentially would be any function like sum or average. It can be min, max, and there are some other window functions which are commonly used as well, and we'll talk about them, such as row number, rank, dense rank, etc. So now you would specify first which function you are going to work with. Over is a keyword which signifies to the compiler that this is actually a window function that we are using. And then in the parentheses, you write over what or which rows you want to compute this function. Now, there are two key portions of this clause here, which is partition by and order by. So partition by is sort of what you would use in your group by. If you had a column and you wanted to, like if you had a column called city in a data set and you wanted to group by city and get maybe the average income in a city, let's say, then your window function would be average of income being the column over partition by the column city. Now you may or may not need order by, but if you wanted to order it by a certain column, you could even add it here. And again, here the order by follows the same default of the order being ascending as it is in a regular order by statement. If you wanted it to be descending, you would add DESC here as well, like you would do in a regular order by statement. Okay, so here is an example, and this should kind of clarify the difference between group by and using a window function as well. So on the left, we have a table of salary by different job titles. And if we just did a group by to get average salary, you would, for the 3 different groups, which are the 3 job titles, you would see the average salary for those 3, and you would get an output with 3 rows. On the other hand, if you would use a window function and compute the average, you would get all the rows as you see in the left image. But the average salary for each of the group is what you would see in the output here. So that's the big difference between using one or the other. Now, for something as straightforward as average, it might not make a lot of sense to use a window function, but when we work through the examples, you will see that where it can be more useful than a group by. Okay, here are just some of the commonly used window functions. Yeah.
So we have 2 questions. Does group by change the ordering? Why is engineer now listed before sales?
Actually, it should not. Maybe there was something else in this piece of code for which this is the output, but actually group by should not affect the order at all. And in theory, you should see either way the same ordering. Perhaps in the code from where this image is picked, there was also an order by for the job title, which alphabetically arranges it. So which is why we would be seeing this kind of output, but neither group by or nor the window function by themselves alter the order for either cases.
Another question, I am not sure I completely get it, but it asks is the group by an aggregate solution?
Not sure I fully follow that as well, but so both are giving you the aggregation. Depends on the use case, whether you only want the output to look like this, being 3 rows, or you want your output this way. Like I said, sorry, go ahead.
No, nothing. I think, yeah, I think it answers the question, or otherwise the person can maybe explain again what they meant exactly.
Yep. Okay, I'll just move on, and if we can get back to it at the end of the session, perhaps.
Yes, definitely. Please go ahead.
All right. Okay, so here are some of the commonly used window functions. The example we saw was for average. You can use it for sum and count. The other ones maybe which look a little bit different from the functions we've seen earlier in the series are row number, rank, and dense rank. Lag, lead, and entile, I don't really want to get into the details of right now for the sake of time, but if anybody is interested, we can talk about it later at the end of the session, maybe. I just want to touch upon row number, rank, and dense rank a tiny bit, because that's something that's very commonly asked or comes up in interviews. So if you wanted to arrange the output by a certain order, or you wanted to count within each group, how many rows are there, and things like that, you would use row number, rank, and dense rank. There are minor differences between these. A row number, as the name suggests, just numbers all the rows. And rank and dense rank sort of do the same thing too, but depending on what computation you're doing, if the value in a column is same for two different rows, rank and dense rank give them the same rank, whereas row number literally doesn't care about whether the values are same or not. It just assigns different numbers to the rows. I think we can better understand that with an example, but just wanted to touch upon it real quick. Let's talk about the last topic in theory, and then we'll jump to some examples. So common table expressions, or CTEs, are another kind of way to make queries look simpler and less complex, more easy to read. These basically operate just like a subquery. The syntax is a little bit different, and they're not nested inside a query as such, like a subquery is. But the idea is the same. So if you had a table, you can first kind of filter on it, do whatever you need to, put it in a separate code block, and then you can use that code block anywhere else in the SQL query. So if we look at this example, we have a table called cameras with ID, the brand of the camera, model, price, etc. So now if we wanted to look at the average, do some operations on this data. So what you see here in the kind of highlighted block is a CTE being used. So it starts with a width, WITH, and then you give your CTE or that block of code any name. Here we are calling it average price brand. And then you just use the keyword as. So this is how you would start your first CTE. So with the name of the CTE as, and then in like parentheses, you would just write whatever query you need to for a specific table. So here we are selecting brand and average price from the table cameras and grouping it by brand. So here the CTE ends basically. Next portion is just the code. And what we are doing is, again, we're using the table cameras and then using this CTE, which is already grouped by brand, and joining the two to get a bunch of other columns. Now, in this case, we're using just one table, and the CTE also uses that. So it's sort of like a self-join, but that's not necessary. You can use two different tables. One can be put into a CTE, and then you join it with a different table. You can have more number of tables also. So it's just a way to simplify your queries a little bit. Okay, so as we said, they operate very similar to subqueries. But the thing is, when you put them in a different block of code, the result set is kind of within the output of that query. And you can use that as a table in the rest of your SQL code. And as I mentioned, it's also makes it very readable, easy to debug, and all of that. Okay, so we're at the end of the theory. I'll quickly pause for any questions.
Yeah, we do have a few questions, Sneha.
Okay.
So let's start at the top here. Does the group by change the ordering? No, we already took care of that. I'm on the wrong screen. Sorry about that. Just to make sure I'm understanding, the question says, a CTE is a kind of like a JS function.
I am not sure what a JS function is, but you can think of it as like a temporary table, or in some cases we create views in SQL where it's sort of a temporary table which just gets computed, and the output can be utilized in any other portion of the SQL code, and you're not actually creating a table. So a CT is kind of very similar to that, but I'm not sure what a JS function is. I'm sorry.
Yeah, I'm not either. I'm so sorry, but thank you for that. There's also another question. What was the on used for?
Um,
I don't see what the.
I'm not sure where
Yeah, I'm not.
or what the context is.
If that was your question, maybe you could clarify for us, and we can kind of help you better. I'm not
Is it
sure either.
possible to
Sneha.
join in the last line on?
Oh, possibly.
Yeah.
Okay. Yeah, so basically because we are joining like the CTE, which has brand as one of the columns, and the camera is stable again, and you're joining on that brand column. So here in the CTE, brand would be like a single row, and it would be unique with the average price against each brand. And you join it with the camera's table to kind of get the model, the ID, the price, and the average.
Thank you.
Mm-hmm.
A question about CTEs in the real world. Is it the preferred form compared to subquery? I don't think. Go ahead.
I think it's hard for me to say if it is preferred, but I will say this, that many times, like personally for me, I use CTEs a lot, and I prefer using joins where I can. When the SQL code gets really large and really complex, I will also throw in some subqueries there and replace the joins with those. But CTEs are fairly common in the real world, because of the reason that it's more easy to debug. So you know which block of code you can go to and fix the code there. So it's really common to see CTEs actually.
Thank you. A few more, if you don't mind. So I think this next question from Jessica here says, so it's just something you can call later. It's a saved bit of code is what I mean. So I think we're referring back to Windows functions, or I'm not entirely sure, but does that question make sense to you?
No,
or CPEs?
I didn't get the question, Lindsay.
Perhaps it's a follow-up to an earlier question and I'm just confused. So Jessica, if you don't mind clarifying for us a little bit, we'll come back to that. And then the next question is a subquery like a table merge?
A table merge. Not sure what that might mean, but basically it is just doing some computation on one of the tables or one or more tables. You can even use a join inside the subquery, but you're doing like one piece of logic and nesting it inside your overarching logic, if that makes sense. I wouldn't think of it as merging.
Agreed. Okay. I think that covers all the questions, unless anyone else has something else they'd like to ask before I move on.
Okay, thank you, Lindsay. Yeah, so please definitely use this channel. We post some questions. There's some good discussion that's been happening from all the participants there as well. So definitely please join that. We also have a feedback form that is shared or will be shared in the chat box. Please take a minute to fill that out as well, so we can improve future sessions. and try to add more value for you guys. Okay, with that, I would like to take everyone through a few examples. So we will use the same platform as we've used in the past. The link is here. So let's move over to that. Okay. Give me 1 second, I'm just trying to find the questions.
We have pasted it in the chat box as well, just in case you're
Okay,
trying
yeah,
to-
I think I'll open it from there. Okay. Can you guys see the platform now?
Yes, Sneha, we can.
Okay, yeah, thank you. All right, so the first question from the doc, just posted here, is getting the count of all doctors who treated a female patient. I also want to call out up front that some of the examples might seem like really simple, but I think it's important to understand the concepts here better. So the idea is not to do fancy or complex queries, but to look at these concepts and understand them in a more simpler fashion, if that makes sense. And we can definitely share out some other more challenging questions for later. Okay, so here we want to get the count of all doctors who treated a female patient. And we have a few different tables. I'm sure a lot of you must be familiar with these by now. So within our patients table, we have gender. So this one we are going to try to solve using a subquery. So the way I like to think of it is I first try to create my subquery. So how I'm going to tackle this is I want to first manipulate the table patients so that I filter for all female patients and I get their patient IDs. So for that, we will get the patient ID from this patient's table. And our condition here is that we want the gender to be female. And because we are going to have this be the subquery, you can just put it in the parentheses. Now we need the count of all doctors, right? So we need the doctor ID basically. Admissions table is the one that has both patient ID, which we use as a key to join to this table. And then we have the doctor ID, which we can count to get our desired output. So now we will say, select something from this admissions table where, so what we're trying to do here is from the subquery, we are going to get a list of patient IDs for all our female patients. And for every value in that list of patient IDs, we want to find the doctor ID from this table. So my where clause will have where the patient ID, and because this is a list, we won't say equal to, or we won't use the equal to sign. We will actually use the keyword in. The other thing I want to mention is if here in the subquery, the patient ID column was called something else. Let's say even if it was called patient IDs, and here actually in your main query, it is something else, you're going to get an error. You won't be able to pick up the values from the subquery. Sometimes it happens that a column in a table used in the subquery is differently named. In that case, what you can do is just give it an alias and make sure that finally the name of that column is the exact same as the column in your outer query table. Right now, we don't have that issue, so I'm going to remove that. Okay, so now we just need the count of the doctor IDs. So we can do this. And usually it's a good practice to do distinct because you're counting all unique doctors. And just say, give it some alias. So basically select the count of doctors from admissions where all the patients are basically your female patients. And that's it. So here in the output, you can see that it's actually 27 doctors. Okay, any questions there? Awesome. Now you could do the same thing with a join. And for that, you would just say select something from the admissions table. And you would join it with the patients table on our primary key, which is patient ID. And again, we need to filter for the condition where the gender of the patient is F. And we basically need the same output. So this should also give you the result of 27. So this is how you could use a join or a subquery, and you would get the same result at the end of it. Okay.
Before we move on,
yeah.
I'm so sorry to interrupt again. I hope it's okay. There's two questions here. One is a suggestion for maybe how participants can understand the concept of the subquery better. It says, I think it would be helpful for to first print the subquery table to visualize an inner query so we can see how we are using an inner query for the main query. So maybe like run the result. Yeah.
That's a good idea. Okay. So yeah, so basically, if we just run the subquery portion, we get a list of patient IDs, as you guys can see. And then this entire list is now becoming the input for your where clause. And you say, for the same value, 6, 9, 12, etc. of patient IDs from your admissions table, count all the different doctor IDs that match those patient IDs. Hope that makes it a little bit more clear. That was a good idea, Lindsay. Thank you. I didn't think of that.
Well, actually, it was one of our participants suggested it, so I can't take credit.
Okay.
They did it good.
Yeah, we have super smart people here.
Awesome. There's one more, a question regarding like and in. So could we use like instead of in a where statement?
So, I think like is usually when you kind of have a string in there. In is used when you have a list of values and not a single or a scalar value, but the list can be anything. Like here we see those are IDs, so those are numbers. And that way you're able to, basically the compiler is able to go through that entire list. And if the value of patient ID from the admissions table matches any of those values in that list, then it will kind of pick that row and count that doctor ID. So in this case, we can't use like. We should be using in. Okay. All right. So let's move on. So I'm gonna put the
Hi, Sneha.
here. Yeah, hi.
Just before you move on, we have a question.
Okay.
Can you explain the difference between using count, star, and the current solution? Just so
Okay.
it's clear.
Yeah. So count star would give you all the rows in the table. Now, count distinct is what I used here. Distinct, as the word says, it's unique values. So if a table had, let's say, 2 rows for the same doctor ID or 10 rows for the same doctor ID, you want to count that as one doctor, right? So you want to only count it once. So in that case, you would use count distinct of whichever column. If you didn't care about something being a unique value of counting different values in a column, then you can just use count star or count whatever the column name is. All right. So the next question is, show the patient ID, first name, last name. Actually, I want to switch it up a little bit. Sorry about that, because I want to get to one example of a window function before we run out of time, and we can go back to question number 2 and 3 after this. Okay, so let's do this one first, if that's okay. Get the running total of height of patients within each city. Now, I know some of these questions like don't make sense, like why do we need a running total of height of people? But I just wanted to come up with something that demonstrates the window function. Okay, so here we're only going to use our patients table that has the column city, which is essentially what we want to group using. And we want to get the total or running total of height. So select something from the patients table. Okay. So here in our select, we let's get everything. I just want to show you guys how it looks like. So I'm going to say P star. I'm going to call my patients table P, which is just an alias. And when I say P star, P dot star, it'll give me all the columns that are already there in this table. Now, on top of that, I also want a running total, which means it is the sum of height. So we will put that in here. So here we're writing our window function. We looked at this keyword over. And now in this over is, this is where we are going to kind of define how our grouping should be and what we want to order by. So here we're saying that we want this running total to be like within each city, which means we want to group by the city. So in this syntax, group by is actually similar to partition by, and we say partition by city. And then we can order by, here we have like birth date. So let's just do that. Not always you need to use order by. Let's just do it now, like just for the sake of example. And let's call it running total of height. Cool. Okay, so this will now actually be created as a new column, which is called running total height from this table. So let's run this and see what happens. Okay, so let me move this.
Hi, Sneha. Just a quick question.
Yeah.
A quick question at the Q&A section. What's the P star?
Right.
Is
so
it? Okay, please go ahead.
so we are calling this patient's table P. It's just an alias or like a pseudo name that we're giving to the table. And we're telling the compiler that from this table, patients, which we kind of nickname as P, get all the columns that are already there in the table first. So star indicates all in SQL language. And then on top of it, add this other column, which is given by my window function. So if you did not want to use this P dot star, you could list out like all the columns here one by one. It's just kind of a better use of my time instead of typing out all those columns to just say P dot star. And in the output, you can see I first get all the columns that are there in the table. And at the very end here, you can see that there's a new column added to my output, which is running total height. Now, if we look at it for 1 second, we will notice that it is first of all grouped by the city. So everything for Ajax, so on and so forth, is grouped together. We see all the rows for this city first, and we said order it by birth date. So in ascending order, we have rows ordered using the birth date column. And the running total height column, first row will just be the height as it is because there's nothing else to add to it. Second row is the sum of the first and the second. Third is the sum of the first, second, and third, so on and so forth. Now, because we are grouping this by city, right here where Ajax, the city Ajax ends, right? The data for that ends. If you look at the first row of the next city, you will see the running total again is 166, which is the first value in this group. And then the next running total in this city group is the addition of 166 and 178. I just want to pause there to see if folks have questions. Okay. Now, you could do, anything over here. You could change this as average. You could make it min, max. You can feel free to like play around with that. And because we are ordering these by a city, by a birth date, you will see the average looks a little bit different. If I remove this order by, the average for the entire group of one city, you will see the same value in all of the rows. There you go. So this is 137.8 is the average height for all the rows in this Ajax city. So all the rows for this city will have this value. For the next city, the average value of height is 157.3. So every row will have that. This is very similar to the example we saw in the slides, which is maybe not super useful, but things like running total is what you would use more in the real world. Okay. I know we're at time. Should we do another question, or do we want to put that in the Slack? Do you have any thoughts, Nancy?
Yeah, I think we can put it in the Slack. We had participants answering questions there as well.
Okay, awesome. Sounds
Yep.
good. All right, so
There's a question in the chat. Can you explain how does it sum the height till the current row only, not the sum for all cities row?
okay, so basically, because we are grouping by the city, it'll look at all the rows that have the city Ajax, for example, and it will only add or average the heights for that city, or it'll kind of do the running total till it kind of ends at this group. And when the name of the city or that group changes, it again starts from scratch. So it will take the first value and plug it in here. Then it'll add the second to the first and put the total here. Then it'll add the third to the second to the first, so on and so forth.